9. How do you figure it's 9?
Because they're both those numbers are divisible.
All right. Well, let's see how we're going to go about trying to attack this problem. First of all, our base is 27. I don't want it. All right. Okay. So let's try. Obviously, 27 to the first, I can do that one in my head. That's 27. Can anybody help me out with 27 squared? 729. Okay? So we can see definitely, yes. We can certainly see that we are not going to be able to rewrite 81 as a power of 27. So therefore, we're going to have to rewrite both sides of this equation. Ladies and gentlemen, can anyone tell me how you can rewrite 27 with a base and an exponent? Correct. So we're going to replace the 27 by 3 cubed. And we're going to rewrite 81. And since we see that we rewrote 27 with a base of 3, that tells us what base we're going to rewrite
3 to the 4th.
81 as, 3 to the 4th.
Yeah.
Thank you. Now, by the properties of exponents, what are we supposed to do with the 3 to the 3rd to the 3x power?
Multiply.
Correct. So we would certainly get 9x.
So it equals 4 nines.
Now that we have both sides with equal bases, we can set the exponents equal to each other. And we can certainly see that we are to get 4 9s.
It's not hard.
Take a look at this example. 256 to the 2x equals 64. So again, you want to try to express your smaller base into the bigger base. So obviously 64 to the first is 64. 64 squared is not going to be 256. So we're going to have to try to rewrite both sides. So start with your smaller base. How can you rewrite 64?
4 to the 3rd.
Definitely 4 to the 3rd is 64. Which then tells us that we have to rewrite 256 as a base of 4. Is everybody with me so far? The key is you want both sides to have the common base. Well, again, by the properties of exponents, when you have power of a power, what do you do with the exponents? Multiply is correct, so that becomes 4 to the 8x and 4 cubed. That means we can set the exponents equal to each other because they're the common base. Guys, what's x equal? 3/8. Questions? Okay. All right, final example. 16 to the negative 3m plus 2 equals 64. Obviously, knowing our powers of 16, we can't write 64 as a power of 16. So, guys, how do we rewrite 16?
4 squared.
4 squared. So I'm going to replace 16 with 4 squared, which means we have to write 64 as a power of 4.
4 cubed.
4 to the 3rd, or 4 cubed. Once again, by the property of exponents, power property as a matter of fact, we multiply the exponents together. So using the distributive property, we get negative 6m plus 4 equals 3. Since the bases are the same, we can now set the exponents equal to each other because that's the only way these two sides can be the same. Ladies and gentlemen, solve that linear equation for n.
1 second. It's 1 second.
All right, so take a look at problem 2. Now we're going to solve exponential equations, but when we have different bases, such as 5 to the 2x equals 130. First of all, check to make sure, can you rewrite 130 as a power of 5? No. So we can't do the same thing that we just did because we can't rewrite 130 as a power of 5. So we're going to have to solve this in a slightly different way. And what is the inverse of an exponential that we learned this week? Starts with an L. A log. So who can put this in logarithmic form?
5 and then log base. I think it's 135.
Log base 5.
And then 130 equals 6.
Very good. Our calculators are not equipped to work base 5, though. They're equipped to work base who? So therefore, we're going to have to change the base, as we learned yesterday. So that would be the log of 130 divided by the log of 5. Someone with your calculator, get me a decimal rounded to the nearest, let's go 10,000th today. Miss Stevens, you got? What do you got? Give me 4 decimal places if you can. Makes sense to me because I know 5 cubed is 125, and that's a little bit more than that. Now, how do we finish this off then to get x by itself, guys?
Divide by 2.
Yes, ma'am. And thus, we find out that in our first problem, am I close? Okay, 1.5122. Okay. Let's do B. Again, thinking about 6, because that's our smallest base, and I can't rewrite 6. So, just to make sure that it's not the other way, 6 to the first is 6. I know 6 squared is 36. Somebody help me out. 6 cubed? Bless you. 216, thank you. 6 to the fourth?
1,296.
Okay. So since we cannot rewrite 512 as the base of 6, we know we have to do it the other way. Ladies and gentlemen, I know Caitlin did the first one. Shelby, think you can write that in logarithmic form?
Log base 6 to the 5
Very nice. Log base 6, 512 equals 4x. Okay. So we have to evaluate the logarithm on the left, but to do that we have to do the change of base because it's not base 10. So again, that's log of 512 divided by the log of 6. 3.4.
No. 3.48.
4817?
Yeah.
Is that what everybody else is getting to? Okay. We can then go ahead and divide by the 4. And thus we find out that x is approximately, help me out somebody,
0.8704.
All students who received a pass for acuplacer testing, please report to the auditorium now. Thank you.
questions on example 2b? Or not 2b? Yes, Ms. Gross.
Why did we
All right, let's go C. All right, we have 12 to the 4x equals 256. Obviously, we have to rewrite both sides. We could try to rewrite both sides with the same base. 12 can't go any lower, and we can't rewrite 12 or 256 as a power of 12. So we have to do logarithms. So that means we have to put it in logarithmic form, and we're going to Zakin. In logarithmic form, yes. I'll get you started. Log. Nope. Yes? Yes? Nice job. So we have it in logarithmic form now. We're going to change the base to evaluate the logarithm because we can't do base 12s on most calculators. Some of them out now will, as I mentioned yesterday. Give me that decimal, please. Jason, you got a calculator?
Not today.
Not today. Lane, you got a calculator, right?
Yeah, Matt does.
No, I gotta get one.
Okay. Kirsten, what do you got?
2.231.
That's exactly what I got.
Then again, or excuse me, after that, we'll divide both sides by 4. I know it's 0.5 something, guys. What is it?